So this brief session, roughly 30 minutes, is going to be about how to write a scientific report. And we as a group, we are pretty heterogeneous, which means that there are people who have written reports. So for those of you who are rather familiar with it, feel free to do other things. And then we know that there are many of you who have never written a scientific report. And the way we want you to present the results is in terms of scientific reports. And many of these reports, the way you write them, they're going to be pretty similar to the way you're going to write your master thesis or any type of technical or scientific report, whether you're dealing with disciplines like psychology, medicine, geoscience, bioscience, etc. The basic ingredients are essentially the same. So the kind of drill which we go through in this course is hopefully something which can serve you when you're going to write your own thesis. Now, today, the aim is more to say a little bit about how to write the report. And you will also see that the exercise for this week is you writing an abstract, an introduction, and setting up the list of references. So when we grade the reports, I mean, not having references means that you get a subtraction of 5 points, and we actually want to avoid that. And it's pretty simple to set up references. I will come back to some of these technicalities. And then when we're done with that, we will essentially spend the rest of the time on the project. And there is a link to a part of the text of Goodfellow et al., which gives a kind of bird's view on what project number 1 is about. Then on Thursday, we are going to dig deeper into the heart of basically all machine learning methods, and that is the optimization part. And we will focus on the gradient methods, stochastic gradient descent, and all of these very popular methods for optimizing a given cost function, objective function. So let me switch back to the Jupyter notebook. And I just wanted to say briefly that you will find this information here about evaluation. If you click on this link, this is the way we will grade the projects. And then there is also a folder with a link to project writing. So the slides which I'm going to show now are essentially contained in this project writing example here. And then there is a LaTeX example file, which also contains a BibTeX file, which you can use as an example for setting up your references when you use overleaf as a way to typeset LaTeX. So LaTeX is a kind of a standard in scientific typesetting, and it's something which many of you will encounter in many other occasions. So let's go back to the Jupyter notebook for this week, or for this session. And this is about how to write a scientific report. And there are some basic elements which we are going to go through. And irrespective of whether you write a thesis, whether this is a master thesis, a PhD, or it's a technical report in a company where you may have a job, the way you are going to set up the report is basically going to contain all these elements. And paying attention to the way you write things is very important, because your credibility in a workplace is often linked with the quality of the reports you write. So, and one of the, well, 2 to 3 of the parts of a report which people normally dive into immediately is the abstract, and that conveys the basic messages. And then you have an introduction and the conclusions. So for those of you who are going to write a master thesis in a not too remote future, the typical thing which an external reader will look at is the introduction and conclusion. And if they are well written, then it's often tempting to actually read the other details. So there are some simple things in introduction and the conclusions which are worth thinking of when you write a report. So I'm just going to go through these elements and discuss them with you. So if you look at the report itself, the abstract is the first thing you encounter after the title and your name. So remember to put your names, and you can obviously hand in as a group, and then the names of all the group members should be there. And this is an example of a report, and you can click on that scientific article, which is an article in astrophysics. So this is an abstract for those who are experts in astrophysics, and when they read that one, they get a basic message of what this article is about. And if you find that interesting, you would keep on reading. And also, like in our case, you may have some specific recommendations. You may say that on messy topographical data with lots of noise or whatever, then a method like Ridge or Lasso works best. And you may find that Lasso with these and these optimization parameters and a polynomial of this order fits well a specific landscape. Just to give you an example on how you could phrase your abstract. So having numerical values is something which you can also place in the abstract. If you find a specific number which people are interested in, and then you would recommend a model linked with that number, then that would typically be in the abstract, and obviously in the rest of the report as well. The introduction is actually worth spending some time on. And the introduction has a typical structure with the 3 elements. So one is the motivation, where you put things in a context. And this is where you typically would say something about machine learning, linear regression. And if you look at the textbook by Hastie et al., if you go into chapter 3, you will find an introduction which contains some basic overarching views on linear regression. So you can borrow text. And there's something I wanted to say in addition to writing the motivation and putting things in a context. So one thing which you should feel free to use are tools like ChatGPT. So many of you have not written scientific English before. And scientific English is a very direct language. Some of you may come from countries where we have many if statements in the language and long phrases, etc., etc. I grew up in a country where a top sentence can actually go over pages, and then you basically lose the reader. Whereas scientific English is a very direct language, like we did this and obtained that. The thing with you writing a text, the thing which many of us will actually do is often we read many articles, and we will find wordings which we like, and we may reuse them. You would also cite it. Now, you can use tools like ChatGPT to get some inspiration. There is a balance you have to make a kind of trade-off with. So writing the introduction is often a very central element of the scientific creativity, because writing the introduction means that you also have to read the background literature and what people have done before, because the first part of the introduction puts everything in a context. And putting things in a context, you have to motivate the reader why what you have done is interesting. So having this kind of motivation leads easily to your contribution. And doing so means also that you have to reference, and it's not always easy to get started with the right words. So feel free to use tools like that, or look into textbooks and other articles and get inspiration from that. Doing so means that you will have to read it, and that can enhance your creativity in the sense that you may get new ideas. So I often write the introduction and the conclusion at the very end. Now we want you to write the abstract and introduction as a kind of, not in the typical chronological order, you would write it at the end. So you would write the findings after you analyze the data, etc., etc. But now we just wanted you to set up a framework. And then when you keep writing on the report, you will get new inspirations for the abstract and the introduction and the conclusion as well. But typically I write the introduction and the conclusions at the very end. And sometimes I spend a week just to find the right words to write the introduction. I don't mean that you should spend a week on writing the introduction, but that for me, that's an essential element of my scientific creativity, because it gives me lots of inspiration by reading what other people have done. Then there is another element which is very important, And this is to emphasize what you have done. So we all tend to be timid, and we don't like to overemphasize or emphasize what we have done. But an external reader, especially in a context like a master science thesis presentation, the external reader or the external examiner is actually interested in your contribution. And if you write in a third person singular and you write in a passive language, it can be difficult for an external reader to assess what you have done. So when you've done the motivation, what you would then come with is a second part where you say, in order to achieve this, we have done this and this. Because then you clarify to the reader what you have developed. In this case, it would be, we have developed a code for doing ordinary least squares, ridge and lasso regression, and we have implemented this on a vanilla type of data like the Franke function, but then we also implemented this on real data. And then you have the things going. And when you've done that, then it's natural to end the introduction with the structure of the report. And then you would say that in order to illustrate all these points, in the next section, we discuss the basic methodology, and then comes the next section with results, etc., etc. Does that sound plausible? That's a typical structure you will find in essentially all scientific articles and all technical reports. So to make clear to the reader what you have done is something which is actually very important, because this is what many readers are looking after. What is your explicit contribution here? You should feel free to use either we or I, and in most cases you will be working as a group, and then it's natural to use the first pronomen, the first plural pronomen. Then the report and discussion of methods and codes is also an important part. And here you have to strike a kind of balance between readability, because you have a kind of red thread you want to present. Many of the things you're dealing with are known. So they've been written in tons of textbooks and articles. So you should, in a way, when you present the basic methodology, you can include parts of the code you have developed to illustrate things you have done, and then link that with a basic theory. Now, some of the derivations is something you will have to decide whether you want to have them in the main text or in an appendix, because some of the derivation may not be too interesting. They're just background. And in our case, many of the derivations are just common in the literature. But like the bias variance trade-off, this is something you could put in the main text, the derivation. And some of the other quantities, like the expectation values, etc., is something you can easily have in an appendix, like additional derivations, etc. One thing which always makes a good impression, in particular since we are dealing with computational projects, is if you're able to compare your code with other codes. In our case, it would be scikit-learn. So when you do your own ridge regression or ordinary least squares, you can compare that with scikit-learn. That's a very good benchmark, because that convinces the reader that what you have done is correct. When you come to your thesis, when you're writing that, having such benchmarks becomes very important, because you will typically develop something new, and you would like to apply that to earlier results. So that shows also that you have been thinking a little bit deeper, and that you know that people have done similar things before. So your new code should reproduce what exists, and then comes your additions. So to be able to benchmark against existing results is something which is very important, because that shows also your understanding of the basic ethics of science, in the sense that you can reproduce what has been done before. And it shows also that you've been digging a little bit deeper, and that you have a deeper insight about what you have been studying. And that's also important. So think of that if you can plug in calculations. And one way to do this is what we have here on the report and the code part. So you can have this material on a website of your choice. But what's often pretty easy is to use GitHub or GitLab or Bitbucket or any of these repositories, and have a structure of your repository which is split into 3 folders. One where you have the report, could be a PDF file or a Word file or whatever, what is your favorite format. Then you would have one folder where you can have some test runs with results, which when we download your report and your codes, when we run them, then we can reproduce these test results. But this is also useful for you, because if you're like me, and I hope not, then after half a year, I would have forgotten what I did half a year before. So going back to such a folder, like this middle folder here, one which contains test runs and so on, tells you what your code is doing, because it's easy to forget all the gritty-nitty details which you plugged into your code. So you will say, what should my code give? I have some test runs here. If I run my code, which I wrote a year ago, this is what I should get. So it's not only useful for us, but it's very useful for you when you pick up this thread again, if you need it. So this kind of bookkeeping, or a kind of a logbook, which you can have with GitHub or GitLab or with version control software, is something which is very useful. And then there should be a folder here which contains the code as well, because we will typically download the codes and look at the way you've structured it and so on. So I should also say one thing. For the first project, typically most of you, since the group is pretty heterogeneous, not everybody is familiar with object-oriented programming. So you will also see the example codes which we have been discussing. These are deliberately written in as simple as possible way. So there's nothing fancy in the codes which I put on. But later, when we come to neural networks, I will show you how you can object-orient it. And if you feel familiar with object orientation, feel free to use that. But in the first project, we actually also in all projects, we will not penalize you if you don't object-orient your code. Because we, as a group, we have people who have just done some simple programming, and then we have people who are very proficient with programming. But we don't want to penalize people because you haven't been programming all your life. Right? So these are things which you should think of. And one of the other things which you can do, instead of having an appendix with additional calculations, you can put them on GitHub. So in your report, you could then refer to additional calculations which have been done to illustrate your main findings in the report. That is pretty common. So like when you run for many lambdas with Ridge, you're not going to plot or present in the main report 100 figures, right? You're going to pick the essential ones, which illustrate what is going on. And then you can have the remaining figures either on GitHub or in a repository like this test and additional calculations, like additional results not presented in the report. And then we can go through them and just see that you have distilled the specific insights based on all the calculations you did. Any questions so far? And it's pretty common nowadays to have a website with supplemental material. So many scientific journals actually don't want all the gritty-nitty details because some of them are actually in textbooks and in previous scientific articles. And if you make a movie, suppose you're studying fluid mechanical problems, it's quite common then to actually make a movie of a wave or whatever, and then you would upload the movie to a website as a supplemental material. That's pretty common. So the results part, obviously you present your results. You should feel free. I mean, there are questions in the exercises which we ask you about. So they should in a way be in the discussion of the results, but we don't want you to discuss the results in a chronological order, like the exercises go like A, B, C, D, etc. But you can choose how you present the results. And we actually want you to break away from this kind of more mechanistic approach which you've done in many of the basic courses, where you answer exercise A, answer exercise B, etc., etc. So we want you to distill your insights in the discussion part as well. And you will have to select what you present, but you should also keep an eye on what we are asking for. So some people have chosen to present the topographical data because these are the interesting results. And then they've had the Franke function calculations as an appendix. That's also one possible way. So you are the one who decides how you want to present your results. But one thing you should pay attention to is that figures and tables, this is something we also give you a score for. So the quality of them. The quality of figures and tables are very important in a scientific article. And many of us, when we read an article, we look at the introduction and the abstract and the conclusions, and then we skim through the figures. So if the figures are badly presented, then many people say, why should I read this? If the figures are well presented, you can actually get most of the results and understand what has been done by just looking at figures and tables. So we are very visual when we read things. And there's always this saying which goes on that a figure says more than 1,000 words. So if you have a good figure, that can be much, much better than many, many words. So I like to have long figure captions, which also explain the figure. So you don't need to dive in the text here and there to read what is being plotted there. So feel free to expand, and the quality of the figures is something during these lab sessions. If you want to discuss that with us, please feel free to do so, because many of you have never written a scientific report. And you're most likely very uncertain about how should my figures be drawn. Make sure that, for instance, the labels on the axis are big enough. It always makes a bad impression if you have very, very small dots on the figure and labels can barely be read. So these are small technicalities which are worth thinking of. And we give you actually some score on the general presentation and the quality of the presentation. So it actually makes, this is actually one of the points which many external examiners and the examiners on your master thesis presentation actually pay attention to. If figures and tables are badly presented, that can be the difference between a good grade and a bad grade. And the other thing with the presentation of the results is that you should provide enough details so that if we want to reproduce it, we should be able to reproduce it. You will be surprised to see how many scientific articles cannot be reproduced because the authors don't give all the calculational details, all the input values. So I've had cases with master students who've spent months because you develop a code and you cannot reproduce what's in the literature. And then you ping the authors and they never respond. Some have left the field, some are even dead. And the thing then is that you start distrusting yourself because you think, I cannot reproduce what has been presented, my code is bad, I'm doing things wrongly. And this is something which, if you present the input parameters to what you've done, that means that other people can actually reproduce what you've done. And that's a very important part of the ethics of science. And this is a kind of minimalistic science ethics, which we will discuss here, making your science reproducible. So I'd say, like in my field, it's 80% of the calculations cannot be reproduced. There is not enough information. If you're willing to set aside a year and reproduce what they've done, you cannot reproduce it. And to me, that represents a big waste of taxpayers' money. And it's also important when you want to reproduce what people have done. If you read in many of the textbooks on machine learning, you will see figures, and there is no explanation how the figures were produced. Like the bias variance trade-off, or the test training and for MSE relation. This is something which many authors just show a pretty rough figure, but they don't tell you how it was generated. The conclusions, actually very important part, obviously. And many people like to often repeat the motivation from the introduction. And then you would restate conclusions which you had in the discussion part. And then after that, you would come with perspectives, right? So even if we have a very simple implementation of linear regression methods, there can be clear perspectives. Like perspectives for future work could be, like in this report, we didn't object-orient the code, and this is something we would like to do in the next report, and so on. So from simple things to more method improvement things. The pros and cons of methods, and another thing which we like to have, and please feel free to do so, is to come with feedback to us. That's equally important. And you won't be penalized if you come with negative free feedback, actually. We don't penalize people. Actually, we appreciate that a lot. And we need it in order to improve what we have here. The additional calculations, so many people now, they tend to skip appendices and have everything on a supplemental website or have it on the GitHub addresses. So this is something you should feel free to do as you want, whether you want to have things in an appendix or you want to place things as additional calculations on GitHub or GitLab or whatever. But this is typically the place where you would also have a listing of the code. But since we will have the code on GitHub, there is no need to have a listing of the code in the appendix. Any questions so far? So these are lots about technicalities and hints and tips on how you can actually write a scientific report. Then clearly the references, I sent you an example file with a LaTeX file, which you can upload to Overleaf if you're using Overleaf. And then you can run this bibtex file. So Overleaf actually does that automatically for you. And it runs the bibtex file and sets up the references. And in that references, you also will find references to the textbook by Goodfellow, Hasty, and so on. And feel free to use that. It's also displayed if you go back to the basic GitHub address. If you go to this project writing link, which you have here, you will find this file reference bib, where I've just picked some specific ones. So this is a scientific article. I have books here, and you will recognize Goodfellow, Bishop, and some of the books we've been using. And then you have reports and theses. So we have a PhD thesis, you can cite like this. Technical report is another option in bibtex. And you have proceedings, and then something which has been published as a preprint. So these are different, I like to sort it like that. And then you can have bibtex files for different topics like machine learning, or you can have it for your specific field, geophysics or bioscience or whatever. Now, the thing I wanted to say a little bit about is also how you can present the references. So if you go back to this Jupyter notebook here, let me show you this by going to a scientific article here. So let me just bring that up. I should have it here. So this is a typical example of how you would set up scientific references. So let me just show you. So a typical way of doing it is you have the name of the author. bibtex provides you with different styles. You would have the title. You don't need to have the title if you don't want it. You have the journal. You can write it out fully, or you can use an abbreviation. So many journals use often abbreviations to save place. And then you have the volume, pages, and the year. If you scroll down a little bit here, you will find an example on how you would cite a book. So this is alphabetical. The nice thing with, if you don't want to have it in alphabetical order, and you just want to have it in chronological order, bibtex actually sets this up for you. So you can find the book by Goodfellow et al., the one we've been using as a textbook here, or we are using. So you will have the title, the author's title, and then the publisher, where it was published, and then the year. You can also have additional page references. So these are typical examples on how you would set up the references in your report. So not having references penalizes you with 5 points. So it's stupid not to do that. And I wanted to emphasize all these things when you're writing the report, because a basic part of good scientific conduct is actually to cite the people who develop things. So you don't give the impression that you have done everything here or developed everything yourself. That's a very important aspect. Any questions so far? So another thing I wanted to also say, and this is something which may be useful for later. So if you look at this scientific article here, which I put up, if you go up here, you will see that most scientific journals, they actually provide you with a BibTeX citation. So you can have a format as a BibTeX. So that means that you can actually transfer this to your BibTeX file. And you don't need to do all this boring typing. In case you're using Word, EndNote is a pretty familiar format for Word. So the typical formats which most scientific journals give you are EndNote and BibTeX. And in the scientific community, I mean in the STEM community, science, technology, engineering, and mathematics, it's, I mean, LaTeX is a kind of standard typesetting program which we use. And then BibTeX is the kind of standard way of using references. You have software which can organize your BibTeX files. And if you're interested, I can show you some examples. So this is just an example of a way you can reference and also set up your, or find the BibTeX references. Now, when it comes to scientific books and articles, etc., as long as you're an IP address of the university, when you click on any scientific journal which the university pays for, you can download this for free. The same applies to many textbooks. So publishers like Cambridge, Springer, Francis and Taylor, and many, many other ones, they have a bundle package they sell to universities. And that means that they often provide a PDF or the EPUB version of the files. There is another resource which I strongly recommend. And we have a center at the University for Teaching and Learning in Science. And they actually have a repository here on how actually to write scientific reports. So you have a link to writing skills. There is also one about active learning, but this on writing skills is actually quite interesting. So feel free to visit that one, because that contains many more hints and tips than those which I cover in these 35 minutes. And then finally, this is just a way to describe me. I love procrastination. Actually, let me see now. Let me just reduce the size of it so we can see it. So there's actually a link down here about how procrastination can enhance creativity. So it's a very inefficient way of working. I don't recommend it, but I love procrastination. And the reason for that is that even if it's inefficient and I keep thinking of things all the time, it really, for me, it unleashes a lot of idea and creativity, because you're under pressure and your brain works under pressure. And then you often, maybe you're connecting some neurons randomly, and then a new idea pops up. I can't explain it, but for me, procrastination works well. For other people, it's just horrible. So my wife, for instance, hates procrastinations. So, and this island to get it done, it's so difficult to get there. It's an older figure because the population is now 8 billion. And I love this industry. There's no industry, and exports, denial, guilt, and justification. So I guess this is a mirror image of human nature in a way. Okay. I wanted to say this because we have deadlines for the projects, and the deadlines are for your planning, but we know that things might crash close to the deadline, so we're always a little bit flexible with the date set. Any questions so far? So what we are going to do now, I'm going to stop the presentation, And I will upload the video a little bit later so you can actually revisit this with the hints and tips. You have all the material online on the GitHub address, and you can always revisit that material.